Hello everyone, warm greetings to all of you. So today we are going to wind up this chapter 5 electricity by discussing lecture 7, which is related to electrical power and calculating electrical billing. This topic is very important, very necessary and very useful and practical topic. So let's begin our lesson from electrical power. What is electrical power? Usually when electrical current flows, work is done in moving charges across the across the circuit. So the rate at which this electrical work is done is called electrical power. So electrical power mathematically can be shown through by dividing the electrical work divided by time, because it is the rate of doing electrical work. So we know that potential difference is actually the work done in moving a charge between 2 points. So arranging the equation of the potential difference, we can equate the work done by multiplying the voltage with that of charge, and we know that charge is also equal to the product of current and time. Why? Because we know that current basically is the rate of the flow of charge. So charge would be equal to the product of current and time. So putting the value of charge in the above equation, we get electrical power we get electrical work to be voltage multiplied by current multiplied by time, and so the electrical energy would be equal to the voltage into current into time. So putting the value of the work done, usually work done is equal to the energy supplied. So we can use both the equation for calculations. So power is actually the rate of doing work or the rate of energy supplied. So putting the value of energy in this equation, we get the final value of power to be voltage multiplied by current. So electrical power is a scalar quantity and its unit is joule per second or watt. Electrical power, we can also use Ohm's law and substituting the value of Ohm's law of voltage or current in the equation of power, and thus we can find that when we put the value of voltage in the equation of power, we get the power to be I square into R. Is that clear? So this is one form of calculating power. In another sense, we can also put the value of current from Ohm's law equation. From Ohm's law equation, we can arrange the Ohm's law equation and put the value of current in this equation. We get the power to be V over R into V. So definitely the power comes out to be V square over R. So we can use this three equation of power for calculating calculation of different questions. So question number 1 is calculate the power of an electrical bulb which consumes 2400 joule in a minute. So here the given value is of that energy consumed, which is 2400 joule, and time is given, that is 60 seconds, that is 1 minute. So 1 minute is equal to 60 seconds. So we know that power is equal to rate of doing work or rate of energy consumed. So definitely doing the proper calculation, the value of power comes out to be 40 watt. Question number 2 is that power of an electrical heater is 1000 watt and it is run for 1 hour. Calculate the energy consumed by it. So power is 1000 watt and that given time is 3600, because it is 1 hour. So we know that 1 hour is always equal to 3600 seconds. So we know that power is actually the energy consumed per unit time. So energy required is equal to the product of power and time, and put the values and arranging the doing proper calculation, we get the value of energy consumed to be almost 3.6 megajoule. Question number 3, a washing machine is rated at 10 ampere 240 volt. Work out its power. The energy is supplied to the washing machine in 40 minutes. So first of all, we have volt, that is 240 volt, current is 10 ampere, and time given is 40 minutes. So 40 minutes is equal to almost 2400 seconds. So we need to find the power. We know that power is a product of voltage and current. We simply do the calculation and the power comes out to be 2400 watt. So we need to find the energy. Energy is equal to power into current. Multiply both the value. The energy comes out to be almost 24,000 joule. So calculation of electrical energy consumed and electrical billing, very important topic. So to formulate the unit for energy consumption for commercial or household purposes, power is expressed in kilowatt and time in hour. Thus commercial or unit of electrical energy is kilowatt hour. So what is kilowatt hour? In a kilowatt, the commercial unit of electrical energy is usually expressed in kilowatt hour. So we usually convert all the watt values into kilowatt, and we, instead of using time in the form of second, we use it as hour. So 1 kilowatt hour is the energy consumed by an electrical appliance of power 1 kilowatt in 1 hour. So the energy consumed by an electrical appliance of power of 1 kilowatt in 1 hour is called 1 kilowatt hour. So let's further analyze or further understand this kilowatt hour by doing further questions. Question is that calculate the electrical energy consumed in units when a 60 watt bulb is used for 10 hours. So we know that power is given in watt. So definitely we have to convert this watt into kilowatt. Watt is a smaller unit, kilowatt is a larger unit. So definitely we know that 1 kilowatt is equal to 1000 watt. We simply divide this 60 watt divided by 1000, and it comes out to be 0.06 kilowatt. Time is given in hours, 10 hour. So electrical energy is equal to power multiplied by time. So 0.06 multiplied by 10 hour, it comes out to be 0.6 unit. So the energy consumed in units is 0.6. Question number 5, calculate the units of electricity consumed in the month of September from the following details. 1 40 volt bulb, 40 watt bulb used for 5 hours daily. 100 watt bulb used for 4 hours daily, and 240 watt electrical fan used for 10 hours daily. So also calculate the monthly bill at the rate of Rs 3 Afghanis per unit. So every unit it cost almost 3 Afghanis. So let's do the calculation one by one. We know that electrical energy is equal to power into time. So power should be in kilowatt hour and time in hours. So for electrical bulb, the power is 40 watt and hour is 5 hour. So definitely we convert the watt into kilowatt. So dividing 40 watt into 1000, it comes out to be 0.04 kilowatt, and hours comes out to be 5 hours. Multiplying both these value, we get the electrical bulb 0.2 kilowatt hour. So in 1 month we know that there are 30 days. Okay, so simply multiply 30 days with that of 0.2, it comes out to be 6 units. So per month this 40 watt bulb cost 6 units. Electrical bulb, there is another electrical bulb, and it is 100 watt and it used for 4 hours daily. So we simply divide the 100 watt over 1000 watt in order to convert this into kilowatt. That comes out to be 0.1 kilowatt. Multiply with 4 hours. Okay, there is 4 hours, and so there is a mistake. It comes out to be 0.4 kilowatt hour. So in a month we have 30 days. So this 0.4 multiplied by 30 days comes out to be 12 units. And electrical fan, its power is 240 watt and used for 10 hours daily. So definitely 240 divided by 1000, it comes out to be 0.24 kilowatt hour multiplied by 10 hours, and we get the value to be 2.4 kilowatt hour. And multiplying this with 30 days, we get the units per month to be 72 units. So the total electrical units are 6 of one bulb, 12 another bulb, 72 of electrical fan. It comes out to be 90 units. And we know that the cost of electricity per unit is 33 Afghanis. So the total cost 90 multiplied by 3, it comes out to be 270 Afghanis. Another question, an electrical heater has a rating of 3 kilowatt, 220 watt. Calculate the following: the current, the resistance offered by the heater, and the cost of running a heater for 10 hours at the rate of 3.5 Afghanis per unit. So definitely here power is given, that is 3 kilowatt. So 3 kilowatt is equal to 3000 watt, and voltage is given, that is 220 volt. So we know that power is equal to product of current and volt. Arranging the equation, so the current it would be equal to power over volt. Dividing both the values, we get the current to be 13.63 ampere. And resistance, we need to find the resistance according to Ohm's law. V is equal to IR, so R is equal to V over I. Put the value, and doing proper calculation, we get the resistance to be 16.14 ohm. Cost of running the heater for 10 hours. We know that power is equal to time, so electrical energy is equal to power multiplied by time. So there is power is 3 kilowatt, and it runs the heater runs for 10 hours. So for 10 hours it cost almost 30 units. So for 10 hours we know that each unit costs 3.5. so for 10 hours daily, the total cost for 10 hours is almost 30 units multiplied by 3.5. so it cost 105 avonis. So this 105 avonis is almost for 10 hours per day. I hope that you have understood the lesson. Do practice the questions, do study, stay happy, and take care of yourself.